Now see next question. Question number 3. Maximize z equals to 7x plus 11y subject to 3x plus 5y less or equals to 26, 5x plus 3y less or equals to 30, x greater or equals to 0, y greater or equals to 0. That means here objective function is z equals to 7x plus 11y and these are the constraints. So with the help of this constraint we have to find the maximum value of z. So first we draw the lines. So we write here, first we draw the lines AB and CD whose equations are 3x plus 5y equals to 26 and 5x plus 3y equals to 30 respectively. So first we take the equation for the line AB. So we draw this table. So we write here in first column name of the lines. So line are AB and CD. Equation of the lines AB and CD are 3x plus 5y equals to 26, 5x plus 3y equals to 30. Now we have to find the coordinate of point lie on x-axis. So point on x-axis, we know that on x-axis y coordinate is 0. So we substitute this. When y equals to 0, we get, when we replace this y by 0 on both, for first point A, we get 3x equals to 26. That means x is equals to 26 by 3. Similarly here, 5x equals to 30. So we get 5x equals to 30 means x equals to 30 by 5. That is 6. So we get coordinate of point A and C which lie on the x-axis. Similarly, we find point on y-axis. We know that on y-axis this x coordinate is 0. So we replace here x as 0. So we get here 5y equals to 26. That means y equals to 26 by 5. Similarly, when we substitute x equals to 0 in second equation, we get 3y equals to 30. That means y equals to 10. So here if you observe, maximum value is 10 because when we divide 26 by 3, we get value 8 point something. Here when we divide 26 by 5, we get value 5 point something. That means here maximum value is 10. That means you can take scale 1 centimeter equals to 1 unit on both axes. So first we plot the points A and B. So point A 26 by 3. Point A lie on x-axis and 26 by 3 means 5 point something. Suppose that point is here. A of 26 by 5, 0. Then second point B. Sorry, point A 26 by 3, that is 8 point something. So we take this point here. This point is A 26 by 3, 0. Point B. Point B is 26 by 5. So this is value 5 point something. So we take here B of 0, 26 by 5. So we have to draw the line passing through these 2 points A and B. Then next point C has coordinate 6, 0. So we take point C here which is on x-axis. Then we require point D. B has coordinate 0, 10. So point D lie on y-axis. So we have to draw the line passing through this point C and D. Now we have to find the feasible solution. So we draw this line passing through the point C and D. Now we check these two inequations for the origin. So when we replace x by 0, y by 0, 0 plus 0, 0 less than 26, condition is satisfied. So we have to mark for the line AB towards the origin. So we mark here toward the origin. Then next inequation is 5x plus 3y less or equals to 30. So again we replace x and y by 0. 0 plus 0, 0 less than 30, condition is satisfied. For this line CD also, so we mark toward the origin. So this is common region which is feasible solution. So this point of intersection of line AB and CD we call point P. So we write here, therefore feasible solution is, or feasible region is, feasible region is OCPBO. OCPBO. Now we have to find the coordinate of this point P. So we write here, P is the point of intersection of lines AB and CD. That means to find the coordinate of point P, we have to solve equation of line AB and CD. So we write here 3x plus 5y is equals to 26. So denote this as equation number 1. Second equation of line CD is 5x plus 3y is equals to 30. We denote as equation number 2. Now here we have to eliminate x or y. So we multiply first equation by 5. So we multiply, or you can multiply by 5 to first equation and 3 to second equation, or you can solve also by using the Cramer's rule. So that is your choice. You have to just find the value of x and y. So we multiply equation 1 by 5. So we write here, multiply equation 1 by 3 and multiply equation 2 by 5. We get. So we multiply this equation 1 by 3. So we get here 9x plus 15y is equal to 78. We multiply this second equation by 5. So we get here 5 5 are 25x plus 15y is equal to 150. So we have to solve this. So you can subtract equation 1 from second or second from first. So you can subtract any one. If we subtract this first equation from second, so we have to change the sign of first equation. So here this plus 15 minus 15 get cancelled. Then 25x minus 9x. This is 16. X is equal to 72. That means we have to find value of x. So we divide both sides by 16. So 72 by 16, which is equal to 4.5. So we substitute this x equals to 4.5 in equation number 2. Put x is equals to 4.5 in equation number 2. So we write here 25 into 4.5 plus 15y is equals to 150. So when we multiply this and simplify, we get y is equals to 2.5. So you can check yourself. X equals to 4.5, y equals to 2.5. So the coordinate of this point P are 4.5 and 2.5. Now we have to find the maximum solution for this objective function. So we have to find value of z at these corner points. Corner points are 0, point C, point P, point B. That is, we have to check origin, point C, point P, point B, which are the corner points of this feasible solution. So we find the maximum value at these corner points. So first we calculate the value of z of 0, then z of C, z of P, z of B. Therefore, the value of z z at corner point r. First we find z of 0. So when we replace x by 0, y by 0, so 7 into 0 plus 11 into 0, we get 0. Then we have to find z of c, that is equals to 7 into 6 plus 11 into 0, which is equals to 42. Then we have to find z of p. So z of p is equals to 7 into 4.5 plus 11 into 2.5. So first we multiply these two terms. So when we multiply this 7 by 4.5, we get 31.5. When we multiply this 2.5 by 11, we get 27.5. So when we add this, we get 59.0, which is equals to 59. Now then next we have to find z of b. So z of b is equals to 7 into 0 plus 11 into 26 by 5. So first we have to simplify this. So we multiply this 11 with 26, we get 286 divided by 5, which is equals to 57 by 2. So if you observe the maximum value we get at point P, which is 59. So we write here, therefore Z has maximum value at P of 4.5, 2.5 and value is 59. Now see question number 4. Maximize z equals to 10x plus 25y subject to 0 less or equals to x less or equals to 3. That means here two hidden conditions are given. First hidden condition is 0 less or equals to x, 0 less or equals to x, and second condition is x less or equals to 3. So we can write this as 0 less or equals to x or x less or equals to 3. That means this first can be written as x greater or equals to 0 and x less or equals to 3 per second. So we can split up this combined form to these two separate inequalities. Again this second 0 less or equals to y less or equals to 3 can be written as 0 less or equals to y or y less or equals to 3. That means we write this y greater or equals to 0, y less or equals to 3. So these two conditions we have to consider, x greater or equals to 0, y greater or equals to 0 for solution in first quadrant, and we use this x less or equals to 3, y less or equals to 3 as the equation. Then third is x plus y less or equals to 5. Find the maximum value of z. We have to find maximum value. So first we draw the lines a, b, c, d, e, f whose equations are. So from this x less or equals to 3 we write equation as x is equals to 3. Then from this y less or equals to 3 we write y equals to 3, and from this last inequation we write x plus y is equals to 5 respectively. So we draw the lines a, b, c, d, e, f with the help of this table. So we write in first column line a, b, c, d, e, f, equation of line x is equals to 3, y is equals to 3, then x plus y is equals to 5. So x equals to 3 is a line parallel to y axis. So we do not get a point on y axis. So we write point on x-axis as A, and on x-axis y coordinate is 0. So coordinate of point A are 3, 0. Similarly, this line y equals to 3 is parallel to x-axis. So we do not get a point on x-axis. So on y-axis we consider that point as D. On y-axis x coordinate is 0. So we get the coordinate of point D are 0, 3. Then E up has equation x plus y equals to 5. So points we write E and E up. So on x-axis y coordinate is 0. So we replace this y by 0. So we get x equals to 5. So the coordinate of point E are 5, 0 and coordinate of E of are 0, 5. Because on y-axis x coordinate is 0. So when we replace this x by 0, we get y equals to 5. Now here maximum value is 5. So we have to take a scale 1 centimeter equals to 1 unit. So we write here scale 1 centimeter equals to 1 unit on both axes. Now we plot all these points first. So point A, which is on x-axis, A of 3, 0. Then point D 0, 3. Point B 0, 3. Then point E of point E has coordinate 5, 0. Point E of has coordinate 0, 5. So first we draw the line passing through this point A, which is parallel to this y-axis. So this is y-axis. We have to draw a line passing through the point A and parallel to y-axis. So we draw a line passing through this point A. This line has equation x equals to 3. Similarly, we draw a line passing through this point D, which is parallel to x-axis. Then you have to draw a line passing through this point E and F. And this line has equation x plus y is equals to 5. Now we have to find the feasible region. So for that we use these inequations. So when we replace this x by 0, 0 less than 3 condition is satisfied. So for this line x equals to 3, we use the condition x less or equals to 3. We replace this x by 0, 0 less than 3 condition is satisfied. So we mark toward the origin. Then we take lines y less or equals to 3. So when we replace here, equation of this line is y equals to 3. Condition is y less or equals to 3. When we replace this y by 0, 0 less than 3 condition is satisfied. So we mark toward the origin. Then third equation is x plus y equals to 5. So we use the condition x plus y less or equals to 5. For this, when we replace x by 0, y by 0, we get 0 plus 0. We know that 0 less than 5. So condition is satisfied. So for this line also, we mark toward the origin. That means this region is feasible region. Now here we get two new points. So this point we call P, this point we call Q. Now we have to find the coordinate of point P. So for that we have to solve these two equations, x equals to 3 and x plus y equals to 5. And for to find the coordinate of point Q, we have to solve these two equations, y equals to 3 and x plus y equals to 5. That means we have to find the coordinate of point P first, then coordinate of point Q, then we find the maximum value of z with the help of corner points. Now see here, point P is intersection of line x plus y equals to 5 and x equals to 3. So we write here point P is intersection of lines x plus y equals to 5 and x is equals to 3. So we substitute here or put x is equals to 3 in x plus y equals to 5. So we get here 3 plus y is equals to 5. That means y is equals to 5 minus 3, which is equals to 2. Therefore, P has coordinate 3, 2. So we write here 3, 2. Then we have to find the coordinate of this point Q. So we write here point Q is intersection of lines. So this point Q is intersection of line x plus y equals to 5 and y equals to 3. X plus y is equals to 5 and y is equals to 2. Sorry, y is equals to 3. Therefore, put y equals to 3 in x plus y is equals to 5. Therefore, x plus 3 is equals to 5. That means we get x is equals to 2. Therefore, Q has coordinate 2, 3. Now corner points are O, A, P, Q. This point is D, O. So feasible region is, therefore feasible region is OA, P, Q, D, O. Now we have to find the value of Z at the corner points origin, at A, at P, at Q, at D. Therefore, the value of objective function Z are, so first we find Z of 0. Z of 0 equals to 0. Z of A, so A has coordinate 3, 0. So we write the value of Z first. So value of Z is 10x plus 25y. Z equals to 10x plus 25y. So we replace this x by 3 plus y by 0. So 10 into 3 we get 30. 25 into 0 we get 0. So 30 plus 0 we get 30. So this is value of Z of A. Then Z of P. So we have to find value of Z of P. So we write 10 into 3 plus 25 into 2, which is equal to 30, plus 50, which is equal to 80. Now next we find Z of Q is equal to 10 into point Q has coordinate 2, 3, so 10 into 2 plus 25 into 3, which is 20, plus 75, which is equal to 95. Then we have to find the value of Z at point D. Therefore, Z of D is equal to 10 into, D has coordinate 0, 3, so 10 into 0 plus 25 into 3. So we get 0 plus 75, which is equal to 75. Now we have a required maximum value. So we get maximum value 95 at point Q. So we write, therefore Z has maximum value 95 at x is equal to 2, y is equal to 3. Or you can write Z has maximum value 95 at Q of